So we're going to start out with a little bit of remembering on these.
Okay.
These first three, hopefully you're not awful. Let's say this was Thursday and Friday. Remember, what is the base of ln? E. So we have E and a log base E. What do those do to each other? Cancel out. So E to the power of ln of x, what's going to be left over? Just the x. These are inverses of each other. So this is just going to equal x. If the base of your exponential and the base of your log are the same, they cancel out. They undo each other. So what about 10 to the power of log 4? Yeah. If there's not a base written, that's the common log. Common log has a base of 10. So this is 10 to the power of log base 10. Again, those two pieces cancel out, and we're left with just the 4. They are inverses of each other. They undo each other. How about the last one up here? Yeah. 5 to the power of log base 5. They cancel each other out. So this one's just going to equal our 27x. Let me bring it down here because it's right on the edge of the wall. They undo each other. They're inverse operations. Okay? So they look kind of complicated. We get stuck on them sometimes, but I promise they're not bad. We're going to work a lot with solving today because we hadn't gotten too much of the solving stuff. So we're going to be using logs and exponentials to solve today. Okay? So simplifying, that's these guys. Sometimes we're going to be asked to solve. So when we say solve, it means I want to know what my variable is. I want to get all the way down to an x equals. That's the goal. So when we're told to solve, that means you want to get to x equals something. That's our goal. Not in the exponent, not anything else. I want x all by itself, x equals something. So if we're given that e to the x equals 6, what can we do to get x out of the exponent? We can write it as a log because we have done this as our BP equals A. That's equivalent to our log base B of A equals P. It gets our powers out of the exponent, this guy. So when we have something like e to the x equals 6, I was like, we are exactly going to wind up at our natural log, but I make a pit stop first. But if you make that jump right away, totally okay. Because I'm going to write this as my log base e, because that's my base here, which becomes my base here. So log base e of my argument, so of that 6, equals my power. So equals x. Switching these things around using our log form and our exponential form. Log base e, that's one of those things that we hopefully know, because log base e is the same thing as ln, that natural log of 6 equals x. And if we're looking for exact answers, that's my exact answer. If we need a decimal approximation, well, we type that in the calculator. So what is our decimal approximation for x? X about equals 1.792. I'm going to take 3 decimal places. So this is our exact answer. This is the decimal approximation. Okay. Hopefully not awful. On the next one, we have one other step we need to do first. I can't just start switching things around willy-nilly on the right-hand one. What do we need to do before I can switch things into log form? What do we need to do first over here? Add 5. In these exponential pieces over here, there's no plus k, no plus anything over here. So we need our exponential piece all by itself and isolated. So we're going to start with adding 5 to both sides. So we're going to have our 4 to the power of 2x plus 3 equals 14. Then what? What can I do next to get that x out of the exponent? If my variable is in the exponent, I need to switch it to logs. Switch it into log form. So this is going to become log base what? 4. This is my base. Of what? Of 14 equals, this whole power up here. 2x plus 3. But I don't want to know what 2x plus 3 is. I want to know what x is. So what do I need to do? Yeah. This left-hand side is going to probably become a mess. But this guy, I can get x by itself. It doesn't matter what's over here. I need the x by itself. So I'm going to start by subtracting the 3. So we're going to minus 3 to both sides. Can I make this be log base 4 of 11? No. This is log base 4 of 14 minus 3 equals 2x. But I don't have my x by itself yet. Divide by 2. So I'm going to divide this side by 2, and I'm going to divide this side by 2. So we're going to have our log base 4 of 14 minus 3 all over 2 equals my x. And that is my exact answer. If we needed a decimal approximation, we would have to do one more thing. Because we can't put log base 4 in the calculator. We talked about it at the very end of Friday, right before you left. Our change of base formula. I'm going to write our change of base up here where we had our log base b of a, which we could do as log of a over log of b, or you could do ln of a over ln of b, either way. So if we needed a decimal approximation, I would need to switch my log base 4 of 14 to be log of 14 over log of 4. Everything else stays the same. And it's gross looking, but that is something I could type in the calculator. You could also do as ln of 14 and ln of 4. Just don't mix and match. So if we need a decimal approximation, do this. If we do not need a decimal approximation, I am completely fine with you leaving it here. So if we need a decimal approximation, you got to do that. Because that'll let us type in the calculator. And then you can type it in the calculator, even messy like that. So I'm going to show you. Oh, it's going to be grumpy about it. So in the calculator, you can come in here and go fraction. And inside my fraction, I have another fraction that has log of 14 over log of 4. Oh, let me close my parentheses. Minus 3 over 2. You can straight up type it in the calculator like that. Even the fractions inside fractions. And that'll give us a decimal approximation of negative 0.548. You do not have to do that every time. I just wanted us to see it in practice and talk through it because I know it has been several days since we mathed. Probably about a week for a lot of us. And I get that. Well, we do have a chapter test coming up this week. Thursday. So we need to remember. Thursday. It is Thursday.
Why Thursday?
Because we need to get some system stuff in before we get into next, like reviewing for the final, and I want us to have plenty of time to review that final. So, we still got a little bit of stuff they need us to squeeze in here.
Yay, finals.
I know. We've got 13 more school days left.
I would be excited.
13.
Stop talking.
Okay. Questions on these two. We're going to practice a couple more like this. Okay, we're going to practice one more just like this, and then we'll go into the other side. All right, so this left one's very similar to the one we just did. What are we going to do first? Yes. We need to subtract that 5. I need my exponential piece isolated before I can switch my form. So we're going to minus 5 from both sides. That's going to give me 10 to the power of 3x minus 1 equals 25. Then what? What next? Yeah, switch it into log form. I need to get the x out of the exponent. So we have our log base what? Base 10. So do I need to write it? Nope, because that is the common log. So log of 25 is my argument. And it's going to equal my power of 3x minus 1. If it helps, you can absolutely put that base of 10 because it helps us keep track of stuff. Totally fine. Totally fine. You don't have to because it's the common log, but if it helps you, write it. What are we going to do next to simplify? We're going to add 1. So this is going to give us log of 25 plus 1 equals 3x. The most common mistake I see is someone will make this log of 26, and that is not okay. You cannot do addition before we get to powers, and logs are based on powers, so order of operations wise, they happen first. We're almost there. What do we do next? Divide by 3. And we're just going to leave this one in our exact form. We're not going to get to a decimal approximation. We only have to do that when specifically asked to. So we're going to have our log of 25 plus 1 over 3. There we go. That's what I'm saying. Okay. So the one on the right is kind of going the other direction. Because now I have an x inside the logarithm instead of being in an exponent. So what should we do over here? Let's divide by 3. The other option would be to use our condensing things, where we take our multipliers and make them powers. Totally fine, absolutely as valid. Gonna be more complicated though. So if you want to, you could take this up and make it be x cubed, but I don't recommend it. I do recommend we come through and we divide by 3 on both sides. Because this 3 and that 3 are going to cancel out. And we're left with our log base 2 of x equals 7. Then what? My base is 2. My power is 7, and my argument is x. So we can rewrite this in exponential form. 2 to the 7th equals x. That's fine. Go for it. Yes. So 2 to the 7th is our x. So the value of our x is 128. 2 to the 7th. Be careful with those. The most common mistake I'll see on these ones is people will switch it because we would much prefer to do 7 squared because it's easier. We know the one off the top of our head than to do 2 to the 7th. So be careful when you're rearranging to make sure you put things in the right spots. And that's our answer on that one. Okay. Questions on either of those two? So hopefully it was doing things we needed to do, but also kind of slowly easing us back into the concept of thinking. All right. I'm going to do a couple more simpler ones before I start throwing some more answers at you. Now we have 5 ln of x equals 35. So 5 natural log of x is 35. Bless you. What should we do first? Divide by 5. Again, not your only option. You can absolutely take our coefficients and make them powers, but you would then have to do a 5th root and icky. It's easier if we take our coefficients and do it this way. Because now we have that the natural log of x equals what? 7. Yeah, so if it helps, because this will be a place where people get stuck sometimes, is forgetting the base on that natural log. I'm just moving that up a line. So if it helps, write this as our log base e of x equals 7. That will sometimes help us when we're trying to switch it back into our exponential form. Because how are we going to write this? What is the value of x? X equals e to the 7th. My base, my power, my argument. And when we have e's, that's our exact answer. We do not need to put that through the calculator to get a decimal unless we're specifically asked for. Because e's are gross. It is an irrational, never-ending decimal. So e to the 7th will be unpleasant. So unless we are asked specifically for a decimal approximation, you do not have to do it. So what are we going to do on this next one?
Put it into exponential.
What's it going to be?
3 to the power of 2 equals 2x plus 10.
Switch it from our log form to our exponential form. Then what? Subtract 10. We also could simplify that 3 squared because that's going to be 9. Minus 10 equals 2x. So that's negative 1 equals our 2x. So what does x equal? X is negative 1/2. Okay. Feeling okay on these ones?
Yeah.
Cool. So I'm going to toss some slightly different ones at you. So now I have e to the x minus 1 equals e to the 2x minus 2. We've seen ones like this left one before, but it's been a couple of weeks. Because we want to find out what x is. So, what can we do? Yeah.
Oh.
You could switch them into log form. You're going to wind up with log base e's all over the place, and they will all eventually cancel out. Or we can go, wait a second, those bases are the same. The bases are the same. So I really want to know when those two exponents equal each other. So I want to know when does our x minus 1 equal 2x minus 2. If your bases are the same, we're just setting our powers equal. We did that back in 5-1. So we don't have to switch it into logs. You can. If you are more comfortable with logs, more power to you. I don't know very many people that are like that. But more power to you. So what can we do here? Minus x and add 2. Bless. So we're going to get 1 I love it when I make mistakes in my note copy. I'm like, I don't match my papers. I don't copy that. Okay. How about the one on the right? What do we need to do over here? Add 5. So I'm going to start with adding 5. So we're going to have 2e to the minus 3x equals 8.
Divide by 2.
Divide by 2. We're going to have our e to the minus 3x equals 4. Switch it into our log form. So we're going to have our log base e, which is the same thing as ln of 4 equals our power, negative 3x. And then divide both sides by our negative 3. So our exact answer, we're going to have our ln of 4 over negative 3 equals x. And that is our exact answer. Again, we only have to get our decimal approximations if we are asked for it. If it's like a story problem and it's like, how long until? Give me an extra number, bless you. But if it's just something like this and it doesn't say to put it in decimal form, don't worry about it. Leave it like that. I know it's ugly, but it is technically the most correct answer. It's okay if it's ugly. They don't have to be pretty. Questions on these ones? Ooh, things are in different order than in my book. Where are those ones? Fun. I get to. Oh, I found it. Yeah. You're like, ooh, I get to experiment if I can't find it in my notes. All right, so we have our 1/8 equals 4 to the 6x plus 2. What can we do here? You're on the right track. Keep going back. Super close. You just got your number swapped. Because we want them to have the same base.
Oh.
What base could they both have?
2.
2. How can I write 1/8 with a base of 2? 2 to the negative third. Because 2 cubed gives me 8. That negative is what makes it flip. How are we going to get our 4 to be as a 2? 2 squared to the power of 6x plus 2. What are we going to do with our exponent 2 and the 6x plus 2? They're multiplied together. Since it's a power raised to a power, I need to multiply them together. So I'm going to distribute that 2 through on our next line. Because now that they have the same base, I really want to just know when those powers equal each other. When are the exponents the same? So we're trying to figure out when does negative 3 equal our 2 times 6x plus 2. I'm just writing it in a full step here just so that we have it and we know where things came from. If you do that distribution all at the same time, I'm 100% okay with that. You do not have to write it as separate steps. Because we need to distribute this 2 through. So we have our negative 3 equals 12x plus 4. Then what? Minus 4. So we have minus 7 equals 12x. How do I finish it? Divide by 12. So we're going to have negative 7/12 equals x. Does that simplify? No. If it did, I'd want you to simplify it fully. But it doesn't simplify. one on the right, we've seen problems like before, but it's been a hot minute. So questions like the one on the left, because that was about like 5 and 1, it'd be 5, 2, which we haven't done in like a month. What do we notice about the one on the right? You can't add the e's together because they have different exponents. You don't necessarily want to add a 15. But what I have here, I'm going to rewrite this real fast just so we can see something and see if we notice what I'm hoping we notice. What if I wrote this as e to the x squared plus 2 times e to the x minus 15. Do we see anything now? It's a quadratic type. It's vaguely quadratic-esque. I've got something squared plus something times that thing minus 15. So what we're going to do here is when I have like an e to the 2x and an e to the x in the same problem, do a u substitution. So I'm going to set my u to be this piece here, my e to the x. I always pick the middle piece. It makes it easier for you. So I can then rewrite this as u squared plus 2u minus 15 equals 0. How can I solve that? Just the u part. Say louder. Yeah, factor it. Multiplies to be negative 15, adds to be positive 2. That's going to be negative 3 to positive 5. So we can put this in our factored form of u plus 5, u minus 3 equals 15. And if you need it, do the little frame. R minus 15, positive 2, positive 5, negative 3. So what are our solutions for u? U equals negative 5, and u equals positive 3. But I don't want to know what u is. I want to know what x is. So now I'm going to go back and substitute that in. So we're going to have our e to the x is negative 5, and e to the x is 3. So how do I get my x's by themselves? So we have our natural log of negative 5 equals x, and our natural log of 3 equals x. Why? Because that was going to be my next question. Are both of these okay answers? Because what cannot be negative in logs? The argument and the base. Do we have a negative base or a negative argument here? That negative 5. Because the calculator gives you a domain error. So this, we cannot have negative arguments. So this is our only solution over here, the natural log of 3. The textbook loves to throw these quadratic type problems. They really do. They throw them in lots of places. We haven't hit them on the assignments tons of times, but almost every section has at least one of these quadratic types. They love to throw them. What's up? Okay. questions on that one? I'm going to do 2 more. First one will be short. The second one will be slightly longer, but not much. We'll do these 2. And then you'll be in a really good place. We can do some more tomorrow if you guys would like, or we can start working on review. We'll probably do a couple more tomorrow because there's a little more we haven't seen, but you can do it. All right. So if we have 16 to the x plus 9 equals 4 to the x minus 2, what are we going to do? 4 squared. Get them to be a common base. I can write this as 4 squared to the x plus 9 equals 4 to the x minus 2. What next? Our bases are the same, so we really only care about when those exponents equal each other. We need to make sure we remember to multiply my square times the exponent on the outside. So we really have 2 times x plus 9 equals x minus 2. So that's really going to be 2x plus 18 is x minus 2. Then what? Subtract x. And we're going to minus 18 on both sides. So we're going to have 2x minus x gives me 1x equals minus 2 minus 18 minus 20. The one on the right, do we have any way of making them have the same base? Like, I can't write 2 in terms of 3, nor can I write 3 in terms of 2. So we're going to have to actually use some, like, log things here. Ew. As long as I do the same thing to both sides of my equations, I can do whatever the heck I want. So what I can do is I can take the log of both sides, which is what I'm going to do first. And you can pick either to use one of the bases that you have there. So I could do log base 2, I could do log base 3, I could use the common log, or I could use the natural log, all of which are valid options for different reasons. I'm going to go ahead and use common log. I feel like that is easier to my brain, but there's lots of ways to do it. So I'm going to, first things first, just log both sides. I'm going to keep everything else the same. I'm going to take the common log of 2 to the x plus 7 and have that equal the common log of 3 to the 2x. Now I'm going to use my log properties. Exponents can come down and be coefficients. So just like our expanding and condensing stuff, I can switch those. So I can make this be x plus 7 times log of 2 equals 2x log of 3. I want to be able to get my x's together, and I don't want to have to divide the x's from each other. So what I'm going to do is I'm going to multiply out this side. It's going to look real gross here for a hot second. So we're going to have x log of 2 plus 7 log of 2 equals 2x log of 3. I want to get my x's on the same side of the equation from each other. I'm just going to go through this fast because I want to make sure we get there in time. So I'm going to minus this whole chunk, x log of 2, from both sides. have our 7 log of 2 equals 2x log of 3 minus x log of 2. And then we are going to factor out an x on the right-hand side. 2 log of 3 minus log of 2. Factoring out the x. How will I get the x by itself? By that ugly thing. So my x is going to be 7 log of 2 over that whole hot mess of crazy. 2 log 3 minus log of 2. So they're not always pretty. And we will practice a little bit more solving stuff tomorrow, but that's the end. If you want a copy of the chapter review, I have them up here on the table because chapter test is Thursday.